So here in 100 ml of water, I just add 1% of salt. In this 100 ml of salt water, now in this salt water, if I take 10 ml of salt water, 10 ml of salt water. So in that, can you tell me how much amount of water it contains and how much amount of salt does it contains? In 100 ml, 1 ml is salt, means in 10 ml, how much ml will be salt, how much ml will be water? In 100 ml of water, in 100 ml of this salt water, we are having 1% of salt. Then if you take 10 ml of 0.01, it is 0.0 0.1 ml of 0.1 ml of, in 10 ml you will be having 0.1 ml of salt. So you can take 10 ml, or if you take 1 ml of salt water, you will be having 0.01 ml of salt. So this is what called uniform composition. Anyhow, if you take in anywhere, if you take just a small strip of water, in that the mixing, the amount of salt mixed in that small portion will be same only. Okay. And if it is heterogeneous, means what is heterogeneous? Non-uniform composition. Say example, instead of putting 1 milligram salt, if I put 50 milligram salt, what will happen? What will happen? Does that entire 50 milligram salt completely dissolved in this water? Completely dissolved in this water or not? Does the 50 mg of entire salt completely dissolve in this water or not? No. So some of the salt only is completely mixed, and in bottom portion, you will be having more amount of salt mixed in the bottom portion. So the top portion of water is less salty, in less salt taste, and bottom portion of water is having too high amount of salt taste, sour taste. So that is called a heterogeneous mixture. So if the composition is uniformly mixed, then the properties of the mixture also is uniform only. If you take a small portion, the properties is same. If you take the entire large portion, the properties is same. So this homogeneous mixture only is called as the solution. Homogeneous mixture only is called as the solution. Is it clear? Okay. So we know that in chemistry, we will be studying the characteristics of matter, structure of matter, and how the matter will be transformed from one form to another form, and how much amount of energy will be released during the transformation. So this is the main purpose of matter. So every material which we face in our day-to-day life mostly will consist of 2 or more components mixed to it. Okay. So in chemistry, study about the solution is one of the most basic term. Okay. So in this chapter, we are going to study about different forms of solution. The first thing is different forms of formation of solution. Okay. Formation of different types of solution. The first thing. Second thing, the solution is characterized by the term called concentration. What is the term? Concentration. So here I told, right, if you add 1 milligram salt in 100 ml of water, 1 ml of salt in 100 ml of water, this 1% is known as the concentration. If you add 50 ml of salt means it will be 50% concentration. So how much amount is mixed, that is called describing the amount of mixture, describing the amount of matter or amount of solute is known as the concentration. So how can we express the concentration of solution in different units? Concentration of solution, we are going to express the concentration of solution in different units. And the third thing, the properties and the behavior of solution can be explained by two rules. One is Henry law, one is Henry's law, and another one is Raoult law. And so any solution which obeys the above law is known as ideal solution. Ideal solution, exactly, they obey the rule, that is called ideal solution. But most of the solution that we are using in our real life will be non-ideal only. So we have to so first we have to differentiate the ideal solution and non-ideal solution, and from that we have to differentiate, we have to explain the how this real life solution, how this real solution is deviated from, so deviation of real solution from the Raoult law, Then the properties is here, colligative properties of solution. Colligative properties of solution. After that, we need to study colligative properties of solution. And in that, if there are any abnormal colligation properties, so say example, if you face some anomalous behavior of solution, so for that anomalous behavior we have to study the abnormal colligative properties of that solution that we need to study. So this is these are all the objectives of the solution chapter. So in today's class, we will be dealing about the formation of different types of solution and concentration of solution. Okay, so in this chapter, we know that solution is the homogeneous mixture of two or more components. So in our chemistry, we are going to take only two components, that is called binary solution. So binary solution means only two components are mixed. Okay. So before going to start this chapter, first we need to understand in solution we have two different terms. Solution basically consists of two things. One is the large quantity, which is called solvent. The another one is the quantity which is going to solve with this solvent, that is called solute. Am I correct? Based upon this solvent only, the physical state is decided. Physical state means whether the solution is liquid, the solution may be sometimes solid, the solution sometimes may be gas also. So that decides by the physical state of solvent only. Okay. So make a note of this. So next we will see about the different examples for the formation of solution. You don't need to note this. You don't need to note this. Just make a note of this, and after that write this. types of solution. So types of solution means the physical state of solution is decided by the physical state of solvent. So the solvent may be either gas or liquid or solid. So types of solution. Say example, if the type of solution is gaseous solution, so if we have gaseous solution with us, so gaseous solution means the solvent should be gas only. The solvent should be gas only, and solute may be gas or liquid or solid. Are you able to follow me? Okay. So in gas mixed with the gas. So what is the basic example? Atmospheric air. So atmospheric air mostly consists of nitrogen, oxygen, carbon dioxide, etc. Am I correct? So that is the one example for the gas mixed with the gas. And when liquid is mixed with the gas, so sometime in an oxygen, so when we breathe oxygen, there may be humid oxygen also. Humid oxygen means if oxygen contains more amount of water molecules. If oxygen contains more amount of water particles, that is called humid oxygen. Or when chloroform, we know about chloroform, CHCl3. When chloroform mixed with nitrogen, it is also example for liquid in gaseous solution. Okay. Now, water vapor. When water vapor, mostly water will be at the steam form only. Okay, so it is the example for gas and gas only, because water will be in the form of steam. So we cannot say water vapor as the example for liquid in solvent solution, liquid in gaseous solution. Okay. Clouds is the example for it is the example for it is not actually considered as the solution. Clouds is called as the collide. What is it? There are some other category. We will study that category in the last part. Our surface chemistry will be studying. So clouds is the improper mixing of two liquids or two solids or two gas. So in clouds, the liquid is suspended in the liquid is spread in the surface of the gas. Okay, then only, so it is not completely mixed with the gas. Okay, say example, if you have water, in that water, if you drop a sand, the sand particle is floated on the surface of the water. So that is called colloidal solution. So that kind of colloidal solution only, cloud is that kind of colloidal solution only. So in cloud, water particles are suspended in the surface of the air, surface of the gas. Okay, so it comes under different category. Okay, and so here when solid is mixed with the gas, say example, we can take camphor. So the special property of camphor is If you just heat it up, it doesn't melt it. It will be directly converted it into a steam, directly converted into a vapor. Am I correct? If you heat the camphor, it directly converted it into uh, what vapor. So when this camphor is mixed with nitrogen, when this camphor is mixed with nitrogen, so that is called the example for solid mixed in gas. And here, similar to cloud, in when solid is floated on the solid is suspended on the air solution, say example, smoke, fog, fog, these are all example for when solid particle is floated on the surface of the air. It is called smoke and fog. And when the liquid particle is suspended on the air, it is called as cloud. So that comes under collides. Smoke, fog comes under collides. So in collides also we have two things. One main material and one small material. If you take paint, it is collide. Curd, it is collide. Milk is the collide. Okay, so that all comes under category called collide. So here we are studying only the homogeneous mixture, right? The next thing, so we have done with gaseous solution. Now we will move on to liquid solution. What is that? Liquid solution. So in that, the main solvent will be liquid only. So solid may be gas, liquid, and solid. So this has the most example. We have solid with liquid, that is salt water, sugar water, etc. You can say when liquid is mixed with the liquid, when liquid is completely solved in liquid, we can say ethanol, that is ethyl alcohol. When ethanol, the petrol, when ethanol is mixed with petrol, petrol or water, that is called a liquid with liquid solution. Liquid in gaseous solution means sometime in palladium material, palladium metal, hydrogen or sodium can be mixed with palladium metal. So solution of hydrogen or sodium in palladium metal. Palladium metal is it is palladium metal is solid, right? Okay, we cannot say like this. Cannot say here. So it is solid. Gas in liquid only we have to say, right? Gas in liquid means in cool drinks we are using carbonated water. Oxygen dissolved in water in marine life. So in pond, in river, so it consists of many marine organisms. So they are living inside the water. So for like fishes, so they need oxygen to survive. So for that, some amount of oxygen is dissolved in that kind of water pools. That is called as biological oxygen demand. That is amount of oxygen required to survive within the water for the organism living in the water bodies. Okay, so we have to maintain the, say example, if you want to say example, if you want to what fish tank, if you want to have a fish tank, in that fish tank should have enough amount of oxygen. Then only the fish can survive with that within that fish tank. So that is called that is the oxygen mixed with water. Like that in cool drinks we have carbon dioxide sometimes mixed with water. So that is called blood also. Yes, blood also. When blood in but blood comes under colloidal solution, so it cannot be pure liquid. It's again colloidal solution. So we are not going to study blood in solution chapter. So it comes under colloids. Okay. Now the third part is solid solution. So the main solvent is solid. In that, if you mix any liquid, say example, liquid means mostly mercury, right? Mercury. When the mercury can be mixed with zinc, sometimes sodium. Mercury can be mixed with zinc or sodium. That when mercury is mixed with these kind of material, that is known as amalgam. What is that? Amalgam. Amalgam mercury mixed with zinc or metal. Like that we can say. When gas is mixed with solid, the example is for gas mixed with solid. For that, sometimes this hydrogen gas and sodium gas, hydrogen just a minute. When hydrogen gas is mixed with palladium metal. So that is the example for gas mixed with solid. And solid mixed with solid, we have many examples like gold jewels. Okay, steel, brass, copper and zinc. Copper and tin, if you use, it is called brass. Copper and zinc, if you use, it is called bronze. Stainless steel we are having. So that are all the example for solid with solid solution. Okay, so these are all some basic examples for types of solutions. Mostly we will be studying about the binary solution only, and in that the main focus is the liquid solid solution, which means solid will be the solute and liquid will be the solvent. So that kind of solution only we will be using most of the time. Okay, so the next thing is the expression of concentration of solution. The next thing is expression of concentration of solution. So hope you can find that table from your textbook. So now we will move on to how can we express the concentration of solution. How can we express the concentration of solution? See. Okay, so concentration. Say example, if you take a tap water or normal drinking water. So the drinking water, we know that the drinking water should have enough amount of fluorine. Which one? Drinking water should have enough amount of fluorine so that only it can help us to avoid the tooth decay. So government bodies, most of the government bodies ensures that, because they are only supplying the drinking water to us. Drinking water to us. So they ensures the proper amount of fluorine in the drinking water. They will ensure so how much amount of drinking fluorine is mixed with this fluorine is mixed with the drinking water. Do you get my point? So if there is less amount of fluorine in the tap water, then we will be facing the problem like tooth decay. Because for the development of tooth, we need fluorine, enough amount of fluorine that we can take mostly from the drinking water only. Okay, do you get my point? And in toothpaste advertisement also, you can see that fluorine advertisement. So our toothpaste contains this much amount of fluoride, so that it stops the tooth decay, like that they advertise. So in that kind of advertisement, they mainly told that this much concentration of fluorine we are having in salt water, in our drinking water. So the amount of fluorine mixed with the water is expressed as the percentage. Say example, 0.1 percentage of fluorine is mixed with our drinking water. So if, say example, if accidentally more amount of fluorine is mixed in our drinking water, then it will become a poisonous gas. Then it will become a poisonous gas. Okay, so whenever we study about the solution, the expressing the solution will be in terms of the concentration. So how much percentage is mixed? How much percentage is mixed? And we may use this unit also, ppm. What is the meaning of ppm? Do you know the meaning of ppm? Parts per million. So in 1 million parts of solvent, how many parts of solute is solved, is dissolved? Like that we can say. And also TDS of water. What is it? TDS. What is the full form? Total dissolved solids. So this much amount of total dissolved solids. So this much amount of salts or solids are mixed with drinking water, or dissolved in drinking water. So this is when they say TDS value means, so if you found any mineral water, in that they mention the TDS value. So TDS value denotes the total concentration of dissolved substances in drinking water. So this concentration is expressed in different units. So for us, we are going to express the concentration as number one, mass percentage. First one is mass percentage. We're going to express the concentration of solution as mass percentage. So mass percentage means we have to take in total mass of the solution, in total mass of solution, total mass. So per kg. How much mass of solvent, solute? How much mass of the component in the solution? So how much mass of the component or solute? Let it be solute. So into 100, into 100. So kg by kg into 100. So it will be in terms of percentage. So for 10 kg, if 1 kg is salt means, if 1 kg is mixed means, so 10% of concentration, like that we can express. Do you understand? And we can also express it by using volume percentage. So volume percentage is the same thing. So total volume of solution, in total volume of solution, the volume of solute into 100, like that you can express. Say example, if they say 10% ethanol solution, they say 10% ethanol solution means, that means in 100 ml of solution you will have 10 ml of ethanol. 10% means 100 ml of entire solution, 10 ml will be the ethanol. So that is called 10% of ethanol solution. And ppm, the third one, C. And we can also express mass by volume percentage also. Mass by volume percentage also we can explain. In total volume of solution, in total volume of solution, total volume of solution, how much mass of the solid? So this will be in the unit of kilogram per liter. Mostly the volume will be expressed in the unit called liter because it will be liquid only, right? So volume of liquid, mostly the actual unit of volume is meter cube. For liquid, we may express meter cube into unit of liter, in the unit of liter. So basically 1 meter cube is 1000 liter. 1 meter cube is 1000 liter. 1 meter cube means you can assume that it is the tank which has the length 1 meter, breadth 1 meter, height 1 meter. So that is, if you pour the 1 liter water to the tank, you can pour 1000 times. That means 1 meter cube tank hold 1000 liter of water or 1000 liter of any material. So volume mostly expressed as in the unit of liter or milliliter. Okay, and mass can be expressed in the unit of kilogram or gram. So mass of solid. Mass of solid. Okay. Then the fourth part. ppm, parts per million. Parts per million. Parts per million means number. You have to express the total number of parts of all components. Total number of parts of all components to number of solid components, number of parts of solid, number of parts of solid into 10 to the power of 6. For 1 million you have to say, so into 10 to the power of 6. So why we are multiplying with the 10 to the power of 6? For 1 million parts, this much fraction. So say example, for 10 parts of the total components, we have 1 part of solution. Then we have to express in 10 parts, you have 1 part. So in 1 million part, how many parts? So that only we are multiplying with 10 to the power of 6. Is that clear? Okay. The last thing is mole fraction. Mole fraction. Mostly we are using this term only. Mole fraction means total number of moles of solution. Total number of moles of solution to number of moles of solid. Say example, if we have a solution in that solvent is, let it be A, solute is, let it be B, and number of moles in solvent is Na. Let me take number of moles in solvent is Na, number of moles in solute is Nb. Then the mole fraction is equal to Nb by Na plus Nb. Nb by Na plus Nb. So if you have more number of matter, so you have to add all those number of moles in the denominator. Is that clear? So this mole fraction only we will be expressing in gaseous solution. In gaseous mixture, we will be expressing by using mole fraction only. So that only explain that only will give the amount of pressure it can be generated when the gases are mixed together. We have to find the partial pressure, the pressure exerted by the gas, that we have to find. For that, this mole fraction only will be very helpful. Okay. Do you have any doubts?